Alright, hey guys, a wonderful day. So basically for today, we are going to learn on stoichiometry. Okay, this is one of the biggest subtopic that we have for chapter 1. And this subtopic especially contributes a lot of marks. Okay, kalau if we look at PSPM 1, tahun lepas, it's almost 20 marks plus. Chapter 1 and chapter 4 is very big, okay, for chemistry. Alright, now, for this part, we are going to learn two things. Number one, balancing equations, which are normal equations and redox equations. And number two, we are going to learn on limiting an excess reactant and also percentage yield. All right, so basically three things. Okay, guys. All right, now let's start off with balancing equations. Okay, now balancing equations, the basic ones, which literally means non-redox reactions, which means there's no charges or anything, you can directly balance it. Okay, now let's have a look. Al plus HCl, basically aluminium plus hydrogen chloride, you'll get AlCl3 plus H2 hydrogen. Okay, how do you balance it? Number one, always remember, look at the metals. Number two, then only go to the non-metals. Right, when we want to look at the metal, number one, look at aluminium. So on the left hand side, there's one aluminium. And on the right hand side, there's one aluminium. All right, aluminium, there's no problem right now. Now, let's move on to chlorine. Okay, on your right hand side, there's 3 chlorine. And on your left hand side, there's 1 chlorine. So we have some problems over here. Okay, let's go through hydrogen. On your left hand side, there's 1 hydrogen. On your right hand side, there's 2 hydrogen. So we do have a small problem over here, which literally means we have problems on the chlorine and hydrogen. Okay, now, if we were to look at the left hand side, aluminium is done. But here we have hydrogen chloride. Okay, here chlorine is 3, hydrogen is 2. What is the common factor? Dulu dah belajar kan maths. Common factor 3, 2, 6 kan? So it'll be 6 hydrogen chloride, 6 moles of hydrogen chloride. And then kalau sini 6 hydrogen, sini ada 2 je. Definitely 3. Okay, sini ada 6 chlorine, sini ada 3. So 2 darab 3, 6. Next, you have to look back again to the metal. Non-metal settle kan? Look back at the metal. Okay, aluminium 2, belah kiri 1 je, tambah je lah 2 depan. So you will get 2 aluminium plus 6 hydrogen chloride, 6 moles of hydrogen chloride plus 2 moles of AlCl3 plus 3 moles of hydrogen. Alright, okay, that is how you solve basic balancing equations, which does not involve charge. Now, what if something involves charge? Okay, what if something involves charge? We have a method, okay? We have a method, and the method is called DBC. For the B, you have AOHCE. Okay, so kalau nak senang, you can use acronyms like DBC, AOC, or something like that for you guys to remember. So divide, balance, combine. Divide first, balance what? Atoms, oxygen, hydrogen, charge, electrons. Okay, how does this thing work? Okay, let's say we are talking about divide, right? Divide, you have to divide. Sini belah sini cakap pasal ferrum atau iron kan? Belah kanan pun ada ferrum. You divide lah benda yang sama, the common ones. Put it as the first equation. Second equation, sini Mn, manganese. Belah kanan ada manganese. Divide that into one common equation. That is how you divide actually. Now, balance. When we are talking about balance, A. When we are balancing atoms over here, make sure you guys focus mainly on metals. But if it's non-metals, only balance the ones which are not oxygen or hydrogen. You can balance anything except oxygen and hydrogen. Okay? Next, when we are talking about oxygen, kalau belah kiri atau belah kanan lack of oxygen, tak cukup oxygen, tambah water. Just add water according to the number of moles that is needed to balance up the equation. Alright, next. When we talk about balancing on hydrogen, you just add H+. Belah kiri lebih hydrogen, so tambah belah kanan H+. Alright, next. Charge. Electrons. Okay, for charge, it's a little bit different, okay? Charge is E negative, E minus atau E power negative 1. So basically it brings negative charge. So anything 1, let's say we are talking about H plus E minus, you will get, H2. So you have to put here 2. Okay? So basically kalau tambah plus E, anything kuasa whatever, let's say X plus E minus, you will get X. Why? Because plus and minus. Electron brings negative charge. Remember that. Okay. Now, next, that is number 1. Number 2, benda nak ingat pasal electrons is, let's say we are talking about 8H plus. This is equivalent, the charge over here is plus 8. So you must plus 8 electrons so that plus 8 here can cancel with minus 8. You will get 0. Baru dia balance. Alright? Okay, that is for charge. Now, electrons, how do you balance electrons? Electrons maksud saya adalah, let's say we are talking about we're balancing electrons, right? Okay, let's say we are talking about on your first equation you have X plus 2 electrons. On your second equation you have Y plus electrons. Okay, so how do you balance this? X2 plus 2 electrons, Y plus 1 electron. How do you balance this? Nak balance ni, you kena darab 2 so that your 2 belah sini akan jadi 2 sini so that you can cancel it. Basically macam simultaneous equation. Same thing over here. Lepas tu, baru boleh combine your final step. Alright, remember DBC AUC. Divide, balance. Balance what? Atoms except oxygen, hydrogen. Then balance your oxygen, then balance your hydrogen, balance your charge, balance your electron, and then combine everything. How do you balance oxygen? Adding water. How do you balance hydrogen? Adding H plus. How do you balance charge? Plus E power negative 1 atau E lah. Next, atau tambah electron, okay? Next, how to balance electron. Electron basically simple concept of simultaneous equation. Now, let me just erase this a little bit. Let's have a look at the example. Okay. All right, when we are talking about the example, number 1, you have to take a look whether the example given is a redox reaction or a reaction without charges. Basically, yang kena peka adalah nampak tak dekat sini ada plus, minus and all those stuff. Dekat tadi tu tiada kan? So you can do as normal and as simple balancing as possible. Sini ada plus, minus and all those stuff. So you have to do step by step. How do you do step by step? Balancing redox equations, you have to use DBCLG. Okay, now, let me show you how do you use it. As usual, Fe2 plus MnO4 minus, you'll get Fe3 plus Mn2 plus. Belah sini, quite obvious it's not balanced. Why? Sebab belah sini ada oxygen. That's first reason. Very obvious. Belah kanan tiada oxygen. Alright, what do? You know, oxygen boleh tambah masa B. Now we are at D. DBC kan? So B ada atoms, oxygen, hydrogen, charge, electron. So atoms, oxygen. Masa tambah oxygen baru boleh tambah oxygen. But to do that, you have to do divide, balance one by one. DBC, AUC. Okay? Now, let's divide it first. Fe2 plus and Fe3 plus. Boleh combine. So you make it one equation. It's not combining, it's dividing. But take like the common factor. Macam tu. Alright? Belah sini Fe, belah kanan Fe. Next, MnO4, you'll get Mn2 plus, you'll get 1. Alright. That is your first step. Divide. Now, balance. Balance atoms. What do they mean by balancing atoms? How do you actually balance the atoms? Balancing the atoms means depan ni ada tak number of moles? Let's say tadi kan 6. Sini 3. So that dia jadi 6 moles of hydrogen. Sini 6 moles of hydrogen. Same thing over here. Depan ni 1. Kalau tiada apa-apa, maksud dia 1. Depan pun 1. So balance lah. Itu atoms, okay? Atoms. Jangan include the charge. Atoms. We're talking about atoms means the item in front of this, in front of the element. Alright. Next, sini MnO4, Mn. Dua-dua ada 1. Mn. Alright, settle. Next, oxygen. Alright, it's quite obvious. Fe2 plus, Fe3 plus, tiada oxygen, so it's balanced. In the sense, okay? In the sense of oxygen. Next, MnO4, Mn2 plus. When we're talking about left hand side, MnO4 minus, and then right hand side you have Mn2 plus. Okay, berapa oksigen dia kurang? 4 kan sebab O4. Okay, remember jangan ambil charge lagi. Charge is the fourth step. We are talking about oxygen, hydrogen dulu. Alright? So O4. So how to balance on the right hand side? Tambah water kan? I said tambah water to balance oxygen. Tapi sini ada 4, so you just put 4 over here. Alright? That is your third step, balancing oxygen. Next, let's balance out the hydrogen. Fe2 plus, you get Fe3 plus. That is balanced because tiada hydrogen atau oxygen involved over here. Okay, so that is balanced. Alright, now. The next one. MnO4 minus plus, I'm sorry, MnO4, you will get Mn2 plus 4H2O. Now, we are supposed to balance what? Hydrogen kan? Belah kanan dah tambah water. So, the moment water, there is H2O. So, belah kanan ada 4 darab 2, 8 hydrogen. So, what do? You tambah 8H plus. Not 8H2, okay? 8H plus. We are adding hydrogen atoms over here. So, this is how you balance hydrogen. Okay, that is your fourth step. Let me just erase a little bit. Over here. All right, okay. Let's move on to the fifth step. What are you supposed to do? Balancing charge can. Charge, when we are talking about charge, it's E. Okay, so now Fe2 plus, you get Fe3 plus. Let's do one by one dulu. Basically kan dia continuous. Apa you dapat dari 1, bawa pergi nombor 2. Nombor 2 punya answer, bawa pergi nombor 3. Nombor 3 punya answer, bawa pergi nombor 4. Nombor 4 punya answer, bawa pergi nombor 5. Macam tu je. Next, how do you balance charge? Sini 2 plus, sini 3 plus. Basically ini ada positive 2, sini ada positive 3. Macam mana positive 3 nak kurang kepada, alright, macam mana positive 3 nak kurang kepada positive 2? Basically tambah negative 1 kan? Logic maths, that's simple maths. So how do you tambah it in chemistry? Nak tambah dalam chemistry, you just plus E, basically 1 electron lah. Kalau dia sini 4, sini 2, sini 2, sini 4, then you tambah 2 electron. Unfortunately dalam soalan ni, Fe2 plus, you'll get Fe3 plus. So 3 plus nak kurang kepada 2 plus, you tambah 1 electron je. Alright, now, let's move on to the Mn, manganese. So we have MnO4 minus plus 8H plus minus plus 8H plus. You will get, I'll write down, yeah, sorry. You will get Mn2 plus plus 4H2, 4H2. Alright, now. Sini, calculation dia macam mana? Sini negatif. Okay, depan ada apa-apa nombor tak? Tiada. So, it's negative 1. Sini positif. Depan ada nombor kan? 8. So, this is positive 8. So, negative 1 plus 8, you will get positive 7. Overall charge untuk belah kiri adalah positive 7. Now, let's have a look at belah kanan. Positive 2. Ada tak depan apa-apa? Tiada kan? So, it's positive 2. Sini tiada charge, 0. So, here is, belah kanan is positive 2. Now, you gotta think how to make 7 to 2. Basically, yang besar kepada kecil lah. Because we tambah electron, when we tambah electron, dia akan berkurang, right? Positive charge. So, you gotta think how positive 7 gotta go to positive 2. So, what you gotta do? Positive 7 plus 5 electrons. Is it logic? Yep. Positive 7 plus negative 5, you'll get positive 2. So, belah kanan, MnO4 minus plus 8H plus 5 electrons, you will get Mn2 plus 4H2. Alright, that is the fifth step. Charge sudah settle. Now, let me just clear a little bit over here. Number 6. How do you do number 6? Alright, now step 6 is basically you gotta balance up the electrons. How to balance electron? Belah kiri ada satu elektron je. Belah kanan, okay, this your left and this your right punya. Belah kanan ada, tadi kita tambah 5 elektron kan. Macam mana nak balance? Darab yang atas tu dengan 5. So what you will get? 5Fe2 plus, you get 5Fe3 plus 5 electrons. That is your left hand side. Your right hand side, what you will get? Maintain, okay? Kenapa? Our concern right now is to remove the electron, alright? MnO4 minus plus 8H plus 5E, you will get Mn2 plus 4H2O. Alright, now, tengok tak? Yang ini lepas arrow baru 5 elektron. Yang ini sebelum arrow 5 elektron. Bermaksud you can cut. Now, what is your last step? Step number 7. Combine dia. Belah kiri, maintain belah kiri. Belah kanan, maintain belah kanan. What do I mean by that? Sebelum arrow, semua combine, atas dengan bawah. Selepas arrow, semua combine, atas dengan bawah. Yang elektron ni, jangan combine. Kenapa? Kamu dah cut. So you will get 5Fe2 plus, always take the top one, yeah? Plus MnO4 minus plus 8H plus, you will get 5Fe3 plus Mn2 plus 4H2O. Alright, this is how you balance redox reaction. Okay guys, I hope you understand the first part of balancing equations over here. Okay. Because this is very important for your stoichiometry. You gotta make sure all the equations are balanced in order to move on to calculations. Kalau equation tak balance, jangan sesekali buat calculation. Itu nombor 1. Nombor 2, kalau dalam soalan, lepas ni kita akan belajar, kalau ada soalan diberi tapi equation tak beri. Buat equation dulu because your calculations are going to be depending on the equations that you do. Alright? Okay, now. Just give me a moment. Okay. Now, let's have a look on what we are going to learn. The second thing that we're going to learn over here is limiting reactant and excess reactant. Okay. What are limiting reactant and excess reactant? Number 1, it's quite straightforward. They are all reactant, bukan product. Maksudnya reactant react dengan something, another reactant akan form product. Okay. Macam tadilah, our equation kan. This one, aluminium is a reactant. Hydrogen chloride is a reactant. Product dia apa? AlCl3 dengan hydrogen gas. Macam tu. Alright? Okay. Now, let's have a look what is exactly or what are exactly limiting reactant and excess reactant. This is the exact definition that you gotta know. Now, let's move on. Limiting reaction. Limiting reactant is the reactant which is completely used up in a particular reaction and it limits the quantity of products formed. I repeat, limiting reactant is a reactant which is completely used up in a particular reaction and it limits the quantity of products formed. What do they mean by that? Okay. Let's say the reactant which is needed, okay, dalam chapter ni, needed and given is very important key point. You gotta know what is needed, you gotta know what is given. Needed is memerlukan untuk menjayakan reaction itu. Tapi given is you beri je. Basically, untuk stoichiometry, given is experimental, but given is calculations, but needed is your experiment. Okay, needed ni is orang scientist dah buat dah dia punya test. So this is the exact amount of grams or this is the exact amount of number of moles needed for this reaction. Given ni, when you are doing the experiment, when you are doing the calculation, soalan dia bagi berapa gram, berapa mole, macam tu. Okay. Let's say, needed dia adalah 3 mole. Tapi, given hanya 2 mole. Jadi, dia akan menjadi limiting reactant. Maksudnya lepas 2 mole ni habis, reaction tidak akan berlaku sudah. confirm reactant semua akan habis. Product is formed, but we don't know how much because it depends on your calculation. Remember, needed given, concept needed given ini. Okay. Next, excess reactant. Excess reactant is the reactant which is not completely used up in a particular reaction and remains at the end of the reaction, berbaki. I repeat, excess reactant is a reactant which is not completely used up in a particular reaction and remains at the end of the reaction. Alright. Now let's move on to the needed and given concept. Okay, let's say needed adalah 2 mol. 2 mol. Usually we use mol ya. Given, tapi diberi 4 mol. Lebih daripada diperlukan. You memberi sesuatu lebih daripada memerlukan. 4 moles is definitely bigger than 2 moles. Definitely dia akan menjadi excess reactant dalam sesebuah reaction tersebut. Okay? Now, that is the basic concept of limiting and excess reactant. Okay. Now, let's move on to a specific formula that I'm going to explain to you right now. Okay, this formula is used to find percentage yield. What is exactly percentage yield? Okay, soalan don't worry, dia akan suruh cari percentage yield atau actual yield atau theoretical yield atau limiting reactant atau excess reactant. Okay, jangan risau. Percentage yield is equals to the ratio atau fraction. Okay, mostly ratio lah. Ratio of actual yield over theoretical yield. Okay, apa itu actual yield? Actual yield, as I said previously, scientists dah buat eksperimen, then that is a specific value. Dia macam your table of relative atomic mass kan? Untuk oxygen is 16 gram per mole, dia punya molar mass. Macam tu lah. Scientists dah buat, so you cannot question much. Okay, actual yield ni selalu diberi dalam soalan. Akan diberi. The actual yield of particular thing is berapa grams. Because yield kan, so it's grams. Okay. Remember, all these are in grams. Theoretical yield pun gram. Okay. Theoretical yield macam mana nak cari? Theoretical yield adalah the equation that you're going to do, the calculation of number of moles that you're going to do, the mass that you're going to find, the limiting reactant, excess reactant that you're going to find. That is the calculation. So, yang you buat calculation tu panjang-panjang is going to be over here. Atas adalah yang diberi dalam soalan. They will give you the actual yield. Darab 100%. Kenapa? Percentage. Alright, okay. Remember, try to keep it on 2 decimal places so that your answer is universally accepted, okay? Tapi dalam jalan kerja, try to put it 4 decimal places so that jawapan terakhir akan jadi accurate as possible. Alright, now, don't worry, jangan bingung-bingung what is limiting reactant and so on. Let's have a look at a question, okay? Alright. The first question, aluminium chloride, AlCl3, can be made by the reaction of aluminium with chlorine according to the following equation. Dah beri equation, jangan guna terus. Check dulu, balance ke tak. Kalau tak balance, you still use it, it's gonna go haywire. Check dulu balance ke tak, okay? 2 aluminium kiri, 2 aluminium kanan, balance. 3 darab 2, 6 klorin kiri, 2 darab 3, 6 klorin kanan, balance, safe to use. Now, what is the limiting reactant? Dia suruh cari limiting reactant. If 20 grams of aluminium, sini 20 grams, 30 grams of chlorine, sini 30 grams, are used. How much aluminium chloride can theoretically form? Theoretically maksud dia apa tadi I dah cakap? Calculation. Sebab itu dia cakap theoretically form. So you have to calculate it. Now, how do we do this kind of questions? Number 1, the basic idea atau basic tip to do this kind of questions is to find the number of moles. Cari dulu number of moles. Kan mass diberi. Cari je lah you punya number of moles. Macam mana? Mass over molar mass. Okay. Untuk number of mole, jangan risau 2, 3, 4, 10, 12 ke depan. Berapa nombor depan ni pun tak kisah. We are going to find the number of moles of aluminium. Okay. Now, let's find the number of moles of aluminium. So it's given mass over molar mass. Please write the full formula ya. formula ada markah. Okay, so 20 over 27, you'll be getting 0.74074 moles. Okay, so sini bawah ni is 27 ya. Basically 27 moles per gram per mole. Okay, now number of moles for aluminium settle. Next, number of moles of chlorine. Mass over molar. Okay, jangan lupa some elements are diatomic. Okay, macam hydrogen, chlorine, bromine, group 17 elements are all H2, Br2, Cl2 and so on kan. Make sure walaupun mass over molar mass, you have to put mass 30 gram kan diberi, molar mass for chlorine is 35.5. Darab 2. Kenapa? Over here 2 kan. Settle. You'll get 0.4225 moles. Okay, that is step number 1. Paling basic. Remember, paling basic, find the number of moles. Apa-apa pun. Alright, sekarang step number 2. Step number 2 is the stoichio that you are going to learn. You have to start with, based on equation, okay, 2 mole react dengan 3 mole kan? So, you write down 2 moles of aluminium reacts with, so sini 2 moles of aluminium reacts with 3 moles of chlorine kan, clearly written over here, 2 aluminium 3 chlorine. Okay, ini react dengan ini, baru you have to find limiting reactant yang akan produce ini. Kenapa limiting reactant? When you have already found what is the limiting reactant, itu akan control the amount of products which is produced. Kenapa? Let's say lah limiting kamu 2 mole, dah nama pun limiting, can it exceed to 3 moles? Cannot kan? So dia akan control apa? Reactant dengan reactant will react, will control the amount of product form. That is the function of limiting reactant. Okay, 2 mole of aluminium reacts is 3 lines. Kalau 2 lines ini adalah equal, yang ini adalah react. Okay, reacts with 3 mole of chlorine. Okay, 2 mole of aluminium react with 3 mole of chlorine. Now what are you supposed to do? Aluminium dah cari number of moles kan? Tulis dekat sini. 0.74074 mole of aluminium reacts with, okay, this is the part which is a little bit confusing. Sini kan you dah cari aluminium. Now, you have to write over on your right X mole of chlorine. Kenapa? Alright, the concept over here is a certain amount of number of mole reacts with another certain amount of number of mole. You dah cari satu, you nak lagi satu. Okay, another way is you can write belah kiri X, belah kanan you substitute dengan 0.4225 mole. Kenapa we do that? Because you want to find the value of X. You nak find X untuk chlorine ke, you nak find X untuk aluminium pun boleh. Kenapa? Because we are going to include 3 and 2 over here. How do we do so? Simple. Darab bahagi. Whatever going up in this equation, bahagi. Whatever going across, darab. I repeat, darab bahagi. So, 3 darab 0.74074 bahagi 2. So, X kamu akan jadi 1.1111 mole. Okay. Yang ini adalah needed. Okay. Remember, maintain 4 significant figure, 4 decimal places dulu because we want to keep the answer as accurate as possible. Okay. Now let me explain to you what is given, what is needed. Soalan memberi apa? 20 gram aluminium. That's why this will be given. Dia memberi 30 gram chlorine. That's why this will be given. Whatever you calculate is needed. Calculation is needed. Alright? So, if you don't believe me, you can put your X for aluminium, substitute 0.4225 mole of chlorine, and then you can find the value of aluminium. You can do either ways. Kenapa? 0.74074 mole of aluminium is for 1 mole. And 0.4225 mole of chlorine is for 1 mole of chlorine. Right now, we want to calculate for 2 mole of aluminium reacts with 3 mole of chlorine. Sebab itu, we do this called stoichiometric equation. Alright. Now, needed adalah 1.1111 mole. Okay. Of apa? Chlorine. Kenapa we put X at chlorine? Let's have a look at chlorine punya given. Given adalah 0.4225 mole. Okay. When given is lesser than needed, that will be your limiting reactant. Kenapa? Secara scientific, needed is you need a certain amount. Memang memerlukan. Tapi, you beri lesser than that. That will become limiting reactant. Let's take a look at reality, okay? You need 10 bricks to create a wall. But you're given only 5. Can you do it? No, you can only maybe do half the wall. That's why it's called limiting reactant. What is the product? The product is the wall. So you limit the amount of products produced. Alright. That's why over here, the limiting reactant is your chlorine. Okay? This will be your limiting reactant. Now, what is the question? What is the limiting reactant? Alright. For you to answer this question, you have to write chlorine is the limiting reactant. Please write full form, yeah? Because given mole of chlorine lesser than needed mole of chlorine. That is how you're supposed to write, okay? Cl2, Cl2. Okay? Given mole is lesser than chlorine, given mole is lesser than needed mole. Kalau dia excess, given mole is more than needed mole. Alright, dia macam tu. Okay, now dia dah suruh cari limiting reactant. First part settle. You want to find how much this atau product is produced kan? Okay, you have found the limiting reactant. I've stated since the beginning, limiting reactant will control the amount of product formed. So just now, we have a 2Al plus 3Cl2, you get, 2Al plus 3Cl2, you get 2AlCl3. 2AlCl3. Okay. Tadi dah cari limiting reactant. What was the limiting reactant? Chlorine kan? Now, you have to do another stoichiometric equation to find what is the amount of product formed. Let's do based on equation 3 moles 3 of chlorine reacts with, produces 2 moles of AlCl3. Cari dulu limiting reactant guna stoichiometric equation, lepas tu guna limiting reactant cari amount of product form. Okay? 3 sini produces 2 sini. Tadi, untuk chlorine, what is the number of mole that we have found? 0.4226 mole of chlorine. We are only using chlorine tau kat sini, bukan 3 mole of chlorine. That's why it's 0.4226. Produces X mole of aluminium chloride. You tak tahu berapa. As usual, darab bahagi. Remember, darab bahagi. So, what you will do? X equals to 2 times 0.4226 over 3. What will you get? You'll be getting 0.28167 moles. Okay. You dah tahu 0.28167 mole is the number of moles produced in this stoichiometry equation atau stoichiometric reaction. Okay, dia cari apa? Dia suruh cari apa? How much? How much maksud dia? Mass kan? In grams. Can theoretically form. How do you find it? Ada mole kan? You have number of moles. Do you know the molar mass? Yes. Rujuk table. Can you get the mass? Yes. Mass over molar mass equals to number of moles. Number of moles is 0.28176. Mass you kena cari in grams. Molar mass. Macam mana nak cari molar mass? Aluminium punya 27 plus chlorine. Chlorine ada berapa? 3. 3 darab 35.5. Remember, put your big brackets over here. You'll find your mass, which is 37.60 gram. That is how you solve stoichiometry. Alright guys, tip. Let me just share a particular tip for you to answer these kind of questions. Number 1, number of moles of reactant. Best is to find number of moles of reactant. Number 2, limiting reactant. Mana satu? Guna. Alright. Number three is guna limiting reactant, cari produk. Number of moles of product. Number 4, remember mass over molar mass equals to number of moles. These are the 4 things. Remember juga, dia boleh jadi from 3, lepas tu pergi 2, lepas tu pergi 1. Kenapa? You dah ada number of moles ini. Let's say dia terang-terang cakap, aluminium is in excess. Kalau dia cakap aluminium is in excess, confirm you know chlorine is the limiting reactant. So go back. Buat benda sama, letak unknown untuk chlorine, you just go backwards. Same thing over here. Alright guys? Okay, I hope this helps you very well in answering stoichiometric equation. And remember the methods of balancing equations. Number 2, remember make sure you balance dulu equation 2, baru buat stoichiometric calculation. Number 3, kalau tiada equation, buat equation dulu. Number 4, techniques in answering stoichiometric equations atau stoichiometry calculation is these 4 things: number of moles, limiting reactant, lepas tu guna limiting reactant cari produk, lepas tu mass over molar mass equals the number of moles. Alright guys, remember cari number of moles untuk satu elemen tu dulu. Masa masuk guna mass over molar mass tu baru darab 2, darab 3 and so on. Okay? Alright guys, I hope this helps. Thank you very much. Have a great day.